be doing a lesson on how to find the inverse of a function. So the inverse of a function is just when we switch the domain and the range. So all we're doing is switching the x and the y values to find the inverse of a function. This is really easy when you have a set of points. It's a little bit more complicated when you have an equation. So just so you're aware of the notation, the inverse of a function is just written as f with a little power of -1. It looks like a power. It really just means f inverse. So here we have a little example where our original function, f of x, it has x values of 1, 3, 8, -1. The inverse of that will have these values switched. All the x values of the original became the y values of the inverse. And all the y values of the original become the x values of the inverse. All we're doing is switching the x's and the y's. So now let's look at this new relation. We have a set of points. So here let's determine whether or not this relation is a function. So we have this point 9, 3 and this point 9, 0, which breaks the function rule. 9 has two different outputs. That's not allowed. So this original relation is not a function. So now let's find the inverse of this relation. All we're doing is switching the x's and the y's. So 9, 3 becomes 3, 9. 4, -2 becomes -2, 4. 9, 0 becomes 0, 9. 5, 5 stays the same because they happen to be the same values. So now let's determine whether or not the inverse is a function. So now because the x's and the y's have switched, these 2 points are no longer a problem because they have different x values. So here, this relation is indeed a function. So now let's look at this graph here. So is this graph a function? So here, if I look at this, if I draw vertical lines, my vertical lines only hit the graph, each vertical line only hits once. So this is a function. So now let's try to find the inverse. Remember, in order to find the inverse, all we do is take the x's and the y's and switch them. So here, this point is 6, -2. So it's going to become the point -2, 6. I just switched the x and the y. Now let's talk about the point 4, 2. That's going to become the point 2, 4. Now here I have the point 3, 5. That's going to become the point 5, 3. Now let's talk about the point 1, 5. That's going to become the point 5, 1. So now the purple dots are the original and the blue dots are the inverse. So now we have found the inverse of the function by graphing it. Now let's determine whether or not this inverse is a function. So now, if you look at the blue dots, if I drew vertical lines down the blue dots, this would be a problem. This vertical line would hit the inverse twice. So the inverse is not a function. So let's try to think about a rule to determine whether or not a relation's inverse will be a function. So if you look at what we originally had here, these 2 points really became the issue once we graphed the inverse. Because this point 3, 5 became the point 5, 3. This point 1, 5 became the point 5, 1. So once they became the inverse, they broke the vertical line test. So hopefully you'll be able to say that the horizontal line test is really what we're going to use to test whether or not a function's inverse will be a function. So the rule just says if a horizontal, highlight this for you guys, how about paper? If horizontal lines are drawn, oh, you can't see that at all. If horizontal lines are drawn through the graph of a relation without hitting it more than once, then the relation's inverse will be a function. So let's try a couple of simple examples. So here, let's determine whether or not this original graph is a function. So if I draw vertical lines through this graph, that lets me know whether or not the original is a function. So here, those vertical lines only hit it once, so the answer is yes. Now let's determine whether or not its inverse will be a function. In order to do that, we draw horizontal lines. And the horizontal lines only hit it once. So its inverse will also be a function. Now let's try another example. First, let's determine whether or not this original graph is a function. In order to test the original, I draw vertical lines. So here, if I draw vertical lines, I get that these vertical lines hit the graph more than once. So this is not a function. Now let's test whether or not its inverse is a function. In order to test whether or not the inverse is a function, we graph horizontal lines and see if they hit the graph more than once. So each horizontal line only hits the graph once. So the inverse will be a function, even though the original is not. So now let's talk about how we're going to find the inverse if we're given an equation. So just like before where we had a chart or a set of points, all we do is switch the x and y. So that's all we're going to do here. If I have the equation y equals 3x plus 1, all we're going to do is switch the x and the y. So I get x equals 3y plus 1. Now I'm just going to solve this equation for y. So I'm going to subtract the 1. So I get x minus 1 equals 3y. I'm just going to divide by 3. So I get that y equals x minus 1 over 3. These two functions are inverses of each other. It's as easy as that. So in the previous sections, we have learned that y equals 3x plus 1 is really the same thing as f of x equals 3x plus 1. So whether it's written y equals 3x plus 1 or f of x equals 3x plus 1, the process is still the same. Just realize that f of x and y are really the same thing. So you can take, if I was given this to begin with, I would still write x equals 3y plus 1 and resolve for the y. Let's just write down the steps of how to solve this for an inverse. So the steps of how to find the inverse of a function are pretty simple. First thing you do is replace f of x with y. If it's given f of x, if it starts with y, then you don't have to do step number 1. Then you just switch the x and the y, and then you solve for y. So here's what we did. All the steps were written out in the previous example. First thing we did was replace f of x with y. Then we switched the x and the y. And then we just solved the equation for y. Just do one more example, and then you can answer the questions. So here, let's just try to find the inverse with this. Step 1 is replace the f of x with y. So this is really the same thing as y equals 1/2 x minus 4. Now I'm going to switch the x and the y. That's step number 2. So I get x equals 1/2 y minus 4. Now all I have to do is solve for the y, basic solving of an equation. So first I'm going to add 4. So I get x plus 4 equals 1/2 y. Now I have to figure out how to get the y alone. I have 1/2 times y. In order to get the y alone, I'm going to multiply by 2. If you want to think about it as dividing by a half, that's the same thing. So if I multiply this whole equation by 2, I get 2x plus 8 equals y. So that is the inverse of my original. Don't forget to answer the questions.